Hello everybody. Today inshallah we're going to continue what we started last time. In the previous lecture we introduced supply chain, lean supply chain. And by saying lean, it means we eliminate everything that is not considered a value adding activity to the customer. And anything that is not a value adding activity in the lean system is considered a waste. So in other words, we have a look at any process and then we remove anything that is not adding to the process, that's not improving the process. And as I told you last time, lean is actually a philosophy. There is no blueprint that we have to follow in order to apply the lean. So I introduced in the previous lecture some principles. The first principle was customers evaluate or identify the wastes or the value. So the first principle says that it's up to the customer to specify whether what you're doing is considered something good for them, something that is adding value to them or not. And the second principle was we need to eliminate anything that is not waste. So we identified different sources of wastes and we defined each of them. The third principle was that if you're going to do different steps, so we have different steps like that, in each step we need to do a process, and that process should be a value adding process. So you need to do things that's adding value to the customer. Today we're going to introduce the remaining two principles. But something to take care about or to note before we start is that for principle number 1, 2, and 3, they can be applied anywhere. It doesn't necessarily have to be a supply chain in order to apply principles 1, 2, or 3. However, when it comes to principle 4, principle 4 needs to be applied only in the case of supply chain. And the principle is based on that customers are responsible for the ordering process. They order. So I need to order, or I need to produce whatever the customers order. And I don't want to produce more than required. So in other words, when the customer orders, I'm going to produce only what the customer orders, and that's called a pull system. Pull system, it's a process in which the production or the actual production is initiated by actual orders. Unlike the case of push, it's the opposite of pull. In the case of push, we don't produce, we produce ahead of the order. We produce against forecast. If we just have a forecast, if we have an anticipation, we expect that we're going to sell this amount, so we're going to produce them in order for them to be ready whenever the customer orders. So we have two different ways of production. The first way, and both of them actually is related to the process of the production. So we have two ways. Number 1 is when we have order, we produce, that's called pull. And the other one, or the other way, if we don't have orders, we just have forecast, and this is a reliable forecast or good forecast or anticipated demand. I'm actually expecting that there will be some sort of sales, so I'm producing against the forecast. or against the anticipated demand. So we have two different ways of production. Both of them, in both of them, we do forecasting. In both of them, we do planning. In both of them, we do everything. The main difference, or the only, or it's not the only, the main difference between the both of them is the timing of the start of the production. In that case, when we have order, we produce. That's the pull. However, for the push, we don't wait for the orders. We produce before we actually have any orders, any coming orders or any ready. So in the pull system, it looks like the customers are getting just what they want. We don't produce other products, just what they want. And it's totally up to the customer to order at which time. So the customer specify, I need this one next week, next month. And the customer as well requires the delivery or the shipping of the product to be for a certain place or to a certain place. So in this slide and the coming few slides, we'll be comparing between the push system and the pull system. The traditional push system, it's the system in which we produce before we have an order. So before the order, we actually produce. So we're producing and we're moving the parts from one station or from one member of the supply chain to the next member. So material is pushed downstream. We push from here to here and we push from here to here. Whenever we finish something, we send it to the next station. As a result, inventory builds regardless of resources availability. So we have here inventory increase and we have here inventory increase. And in that system, we have strong emphasis on the production first. The main point or the main thing that we're taking care about here is we need to produce before the customer orders. We need we need the orders to be ready whenever the customer orders. We don't want the customer to wait. As a result, stock points and additional inventory can overflow with parts and raw materials. Let's have an example. If you notice that next month there will be a big sale at Carrefour. If you have a look at all the branches by the coming 2 or 3 weeks, you'll find that they have extra quantities from all the things that will be on sale. So they will have many TVs, they will have many electronics, they will have a lot of things that will be on sale next month. So as a result, the inventory is full, the warehouse is full, the retailer is full, and everything within the supply chain is full. As a result, if you have a look at the push system, we are going to produce a lot of items. So in order to minimize our cost, we'll find that when we buy a lot of parts. So we make big purchases in order to have a good price. So the price is improved of the raw material. And because we're shipping a large quantity, the result is, if we ship, for example, here, this vehicle costs £1,000. If you ship one item, the cost is £1,000. If you ship 2 items, the cost is £500, and so on. So if the quantity shipped increases, then the price per item decreases. So the shipping cost will be decreasing as well. So we have good price, we have good shipping, however, we have very large inventory. So we have here a large inventory. So inventory cost is very large. And because we're producing a lot of items, so when we make one step, or when we produce product A and then we shift into B, and then we shift into C, we need to spend some time called setup time or changeover time. We change from A to B, and then we change from A to B. And because we're producing a lot of items, so when we stop the machine, we do the setup, we produce a lot of B. So we produce a large quantity of B whenever we have an order. So as a result, the lot size here is a huge lot size. Why? Because we don't want to waste our time in doing setup. When we do the setup one time, we produce a lot of items of A. And then if we do another setup time is where the machine needs to be stopped. The production line, all the production line is on a stop. We stop everything, we set the machines, and then we restart again. So this is taking time, this is taking resources, and it's not producing anything. So we don't want to spend a lot of time here. So whenever we do one setup, we produce a lot of items. The reason is, let's say that this costs £1,000. Again, it's similar to this concept. If you produce a lot, then this amount will be divided by a large number. That's why we produce a lot here. So the lot size here is large, because when you spend something or some resources on the setup, we need to divide by a large number in order for each one of them to have a small portion of the cost. As a result, in all the steps here, we have lots of inventory. We have a large inventory everywhere. Large inventory for the incoming parts, large inventory for the production, large inventory for the finished parts, large inventory everywhere. And even in the production here, we push the product from one stage to the next stage, to the next stage, and so on. We keep on pushing the production. As a result, we produce a large quantity, and we ship or we push this large quantity to the next stage or the next station, and that's basically the warehouse or the customer. So as you can see here, every step is consuming a lot, or every step we're producing a lot of items. We're consuming a lot of resources. And the main problem here, inventory cost is huge. So the inventory cost is huge because of we're producing a lot before the actual demand arrives. So this is good for the items whenever the item has a small inventory cost. When the item has a small inventory cost, then it's possible to use the push system. So number one here, in the characteristic of this system, number one, it's good for whenever we have inventory cost small per item, like the bread. The cost of storing the bread is very small. As a result, we can store the bread. It's also good whenever the customer needs the product to be ready. So we need a good response. So it's good whenever we need a good response. In other words, whenever the customer orders, he needs to find that the order is ready. He doesn't want to wait. So this system is good in that case. And because we're producing a large amount, so it's also good whenever the variety is not that huge. Why? Because we need to stop and then produce a lot of item A, for example, and then we stop, we do changeover, we do setup, and we produce B. So if you have many items to produce, so the variety is large, so you will have a lot of setup, and this is not good in the case of push, because we want to concentrate on producing as much as possible whenever we produce. So it's better for this one to produce A only, or A and B, not to produce A, B, C up to Z. That's not good for the push system. So the push system is good whenever the inventory is low, whenever the response time needed is very small, so we need a high responsiveness. Whenever the variety is not that large. And number 4, whenever the price is not very high of the product, because you're producing before the order. So consider the case if you're producing planes. The plane is very expensive, so we don't want to produce it before the customer orders it. We just produce it whenever the customer orders it. So in that case, if the price of the product is relatively small, we can use a push system. When the price is high, we cannot use the push system. Number 5. Whenever we buy a machine for push system, we need it to be specialized, because we don't want to produce many variety. So we want a machine to be specialized in A, so we don't have to stop every time and change from A to B. This machine is only producing A, for example. This is considered a very good push system, because we're producing continuously and we don't stop for this one. And definitely this is good for whenever we have a large demand, or actually very large demand. So if we have very large demand and the price of the product is not high, so if we don't sell it, we don't regret a lot. And the inventory cost is not actually very high, then we can use the push system. So the push system is good whenever there is a huge demand, like the case of the bread, and the price of the product is low, as the case of the bread, the production of bread, and the response time required is fast. Whenever I buy bread, I need to take it immediately, so we need a response time. At the same time, the cost of inventory is not very high. If you store the bread for 1 day or for a few hours, you don't have to spend a lot of money. So in that case, the push system is very good for that case. Now for the case of the pull system. For the pull system, the customer starts the production process by pulling production when it is needed. In other words, when we receive an order, so the customer here orders a product, then we produce. Actually, this is a little bit misleading, because sometimes we use buffer inventory. In other words, here is, for example, 1 product or 2 products stored. It's a small quantity. It's not like the push system. So whenever the customer orders, he will take one of these 2, and I will be producing one instead. So again, the production here occurs whenever the customer orders. But to improve the responsiveness, we can have some buffer inventory to make the process more responsive. So we can improve the responsiveness. So we have here the production is related to the ordering process. Whenever there is an order, then there will be a new production. So material is moved to workstation as it is needed. So for example, if you're doing first step here and you're doing second step here, we don't move the product from here to here except if we receive a new order, and that in that new order we produce the first step, then we move it to the second step. As a result, we don't store a lot of items here. We just store the ready items here according to the orders. So stock points are kept at a minimum. We don't store a lot. As a result, we don't store or we don't have a large inventory, and by definition inventory in itself is a waste, so we're minimizing the waste. We don't consume products, we don't parts, we don't consume resources, we don't consume wastes, so we're eliminating waste, unnecessary waste. So as a result, whenever we're producing against orders, we're doing a pull system here. So we only produce when we have an order. So most of the time we don't buy the products or the raw materials or the components except when we have an actual order. So as a result, we don't buy large materials. We don't utilize large shipments. We use small shipments. So as a result, in the small shipments, the price will be worse. It's not better than the push system. The price of piece, of the procurement price. And the shipping will be worse. But the inventory cost will improve a lot because we don't have to store a lot. So as a result here, instead of having a large inventory, we have a small inventory. So pull system is good for number one, bulky material or bulky bulky products. Why? Because the inventory cost will be very high. So when the inventory cost is high, we don't use the push system. We use the pull system to reduce the cost, the inventory cost. But we can do some things to improve the price and shipping costs. For the price cost, whenever we buy from a supplier, we agree on a long-term contract. So instead of buying, for example, 1 million item in one shipment to have a good price, we will have a contract that I will be buying this 1 million, but instead of having them in one shipment, I will have them shipped whenever I asked for them. So for example, if for this day I want 10 items, you'd ship 10 items. The next day I want 100, you'd ship 100 items. So in that case here, the selling price or the long-term contract will force the supplier to give me a good price, because ultimately he will be selling 1 million items. So he will have a demand for 1 million items for the coming year. That's a very good deal for the supplier, and even for the supplier itself. Instead of producing 1 million items and have them ready for shipment, he can just produce 1,000. So this is better for the supplier as well. So as an overall performance, this is better for the supplier and this is better for me. But the drawback is whenever we have a dealer here or the supplier here, we have to have a good, reliable supplier. Because if I order 10 items, you need to deliver them as fast as possible, as fast as required. So I need you to be reliable. So whenever I order a certain amount, or up to a certain amount, you need to respond fairly good. And for the shipping cost, we can improve the shipping cost. Shipping cost can be improved by two ways. One way is to increase the utilization of the car, of the vehicle. In other words, when you move a vehicle, it has to be full. And the other thing is to reduce the distances. So in order to decrease the shipping cost here, we deal with suppliers in the nearby distance, not far away. That's one thing. And when we use a car or a vehicle, we can use smaller cars, but we need to have them fully or to have fully loaded shipments. So To summarize what we said so far, in the case of pull system, the amount you're buying from the supplier will be smaller because it's based on the order. As a result, the price will be higher and the shipping will be higher, and the inventory cost will be a lot smaller. So this is an improvement in the inventory cost. However, the price, the procurement price and the shipping price will increase. So we can do two things for them. For the price, we can make a long-term contract with a good supplier that I have a commitment to buy 1 million items, but I don't want to take them in one shipment. I will have them as needed. So today I order 10, you deliver 10. Tomorrow I order 100, you deliver 100. So this improves the price. So the price again is improved. So we improved the inventory price, the cost, the price, the procurement price. And for the shipping, instead of having large vehicle to ship 1 million, we will have small vehicles. But these small vehicles will come from a nearby supplier. So the supplier needs to be in a near proximity to the factory. At the same time, whenever a car is moving from the distributor or from the supplier to the manufacturer, it has to be full. So we improve the utilization. In this sense, we can improve the shipping cost. So when we produce now, because we're producing against the orders, so sometimes the order is A followed by B followed by C and then A again and then B again, and these are small amounts, small amount of A, small amount of C, small amount of A, small amount of B. So when we're producing, we need to produce smaller lots. You don't have to produce a lot of items, unlike the push system. Whenever we do the setup, we produce a lot of items. Now we're producing against the orders. So if you produce a lot of A, if you start A and produce a lot of A, then there will be a delay for B and a delay for C, and we don't want to be late. So we produce small amount of A to satisfy the demand or the orders, and then a small amount of B to satisfy the orders, and so on. But we have a major drawback here. We have a setup here, and we have a setup here, we have a setup here, we have a setup here. So we need to reduce this setup, because we're producing a small amount here, and then we do setup, and then a small amount, and do setup. In other words, we're doing the setup frequently. So we can't consume a lot of time in this one. So we need something called faster setups. We need to do the setup in the fastest possible way. And finally, we have less inventory, because we're producing a small amount here, a small amount here, a small amount here. So our inventory is much more less than the push system. After the production, the goods are pulled by the demand, are shipped against the demand. The production actually occurs when there is a demand. So if you have a close look at this one, and we can, from this we can just conclude what are the characteristics of the products or the process here. Number one, for the inventory cost, it's good for the items whose inventory cost is very expensive. Why? Because this system uses small inventory, which is already expensive in some products. So if your product has a very high storage cost, then we need to use the pull system. Or if the demand is very low demand, if the demand is very low and you produce and store the product, then you're actually wasting your money until there is an order. And when the demand is very low, it's possible that you don't receive any orders in the coming horizon, in the foreseen horizon. So as a result here, if you have a demand as a low demand, we can use the pull system. Number 3, it's good when we have variety. When we have large variety, then we can use pull system. And it's totally dependent on the setup time. If you can change from one product to another product in a fast way, then you can use this one. If you can't do that, then don't use this one. So we use this one whenever there is a there is a variety in the production or in the demand, and you're capable of changing from one production to another production in a good time. So number 3 here, when there is a variety in the demand. Number 3. It's also good, number 4, when the price is high, when the product is very expensive. When the product is very expensive, then you cannot afford making a product and store the product and you don't receive an order for it. It may not be sold. You may lose your money. So you don't risk that. And more important, number 5, the customer accepts that there is a delay. There is some lead time. In other words, when there is an order, the customer waits until I produce. So we cannot be we cannot deal in a very fast way. It's not possible. Actually, it's possible, but however, this process needs some lead time. It needs some time. You don't take the product immediately. It's not like you buy bread. You just go to the bakery and you find the bread and you just take the bread. In that case, it's not possible. There is a lead time. When you order, you need to wait until I produce the product. So these are the main characteristics. Try to think, does it fit planes production? Let's have a look. Number 1, the price. This is very expensive. So there is a high risk if I produce the planes and I don't sell it, there is a high risk that I will be losing a lot of money. Especially that the demand is very high, very low. So we have very low demand and the price is very high. Moreover, the inventory cost is very, very high. So we are going to pay extra money for storing the planes. And whenever there is an order for a plane, it has totally different characteristics. Somebody wants the plane with the leather interior. Other people wanted to be luxury. Other people wanted to be, or other orders wanted to be fit for economy travels. So we have a large variety. So in the planes production, the inventory cost is very high. The demand is very low. There is a variety. Each demand is a totally different product. And the price is very expensive. And whenever I order a plane, I don't expect it to take it immediately. It will take about 1 year, 2 years to be ready. So the customer is okay with having a large lead time or a long lead time. So this is a good example of using the pull system. This is a good candidate of using the pull system. It may seem like I've guided you that using the pull system is better than push system. However, this is very misleading. There is some use, some conditions for using the pull system, and there are other conditions for using the pull system. So some conditions for the pull and some conditions for the push. Number one, if you want to use the pull system, there must be a planning and control responsibility. In other words, if I'm the planner and I plan for the production for 1 month, it can turn out to be 6 months. This is not acceptable. So there must be some control in the production and some control on the planning. If you say 1 month, then try to be 1 month or less. Try to produce it in 1 month or less. So everybody here has to be responsible for his task. Number two, if we need to use the pull system, then we need to understand that we're producing to meet the demand, actual demand, or actual orders. So we need orders to respond to. And another important aspect when you use the pull is we need to reduce in-process inventory. In other words, the inventory needs to be reduced in incoming raw material, and during the production itself we don't want to store a lot of products, we just want to store the minimum possible amount. And for the finished product we don't want to store a lot, we just store very small amount. Number four, as I told you before, there is a lead time between ordering and receiving the order because we're dealing with a pull system. So when we receive an order, we start to producing and then we ship. So during the production here, this production occurs only after we receive an order. So we have an order, we produce. We don't want the machine to stop while producing our product. So what we can do is we need to do a maintenance ahead of any failure. So what we do something called preventive maintenance, like what we do when we service our cars. We do a service each 10,000 K. It's not because the car itself has stopped, it's because that we don't want the car to stop suddenly. So we remove the parts that we expect that they will go bad in the near future, and we replace them with new products or new parts so that they don't fall or don't stop. So in other words, here we have here some machines. So we do regular maintenance in order not to stop whenever we have an order. Because if it stops whenever there is an order, then if we produce in 1 month, we will add the stoppage time. So if it stops for 2 weeks, then the total now is 1.5 months instead of 1 month. We don't want this. So in order to have a good pull system, we need to have a good maintenance system, and we need to do something called preventive maintenance. We do the maintenance before the actual failure happens. Number 5, we need to do something called quality assurance. There are 2 ways of doing the quality. One way is we produce, and after we do the production, we test the product. If it's bad, we go and fix what's bad. And that's a waste, because we're doing the process 2 times in order to fix the bad things. The other way is, let's follow a system, and this system makes sure or assures that you're doing the process in a correct way. So if you follow the system here, and you follow the system here, and you follow the system here, it's very unlikely that the product will be a bad product. It's very likely that the product will be as designed. So I'm assuring that every step you're taking here, you're taking it according to the original plan, and you're doing it in a good way so that the product will be in a good is a good product after the production. One of the important things to focus on when you have a pull system, as I told you, in a pull system, we have a small order for A, and then we change to B, and then we change to C, and then we return to A. So we have different or many setup times. So in a good pull system, we need to have a small setup time and lead time. We need to produce B very fast. We need to change from A to B very fast. So the production time or the lead time and the setup time and the procurement time, we need to buy A, the process for A or the parts for A. So the lead time of procurement and the lead time of production and the setup time, all of them have to be very small, must be small actually. Number 7, in order to have a good pull system, we need to have a connection between all the operations. In other words, we need to know, is there any new orders? Is there any cancelled order? Is there any order that's already finished? So we need a lot of information so that we can plan accordingly. If there is any change, if there is any opportunity. Number 8, demand must be uniform. To explain this one, let's have a look at the sales of air conditioners. The sales of air conditioners, it's very small in the winter, and then on the autumn, and then in February, it will be very large. For the ACs with the air conditioners with the heat exchange or with heating capabilities, and then the sales decrease again until August, and it increases again. The problem in this pattern is, here is the normal production, here is the normal production. If you work with the pull system, you just produce this amount. And then you need to produce this amount, which is a lot more. Let's say this is 100 and this is 1000. During the normal year or normal month, you're producing 100 items according to the demand. But during the peak, you need to produce 1000. And it's very difficult to produce both of them. We need to store items from before, and the storage is against the pull system. So this pattern is not a good fit for the pull system. We need our demand to be a little bit uniform, something like that. There is not a huge change. There is a change in the demand, but not a huge change. Or there is an expected change. But in the case of, we have here a steep change in the demand, very large change in the demand, then we cannot use pull for this. We cannot suddenly, instead of producing 100 items, produce 1000 items. It's not possible. We have to pre-produce these 1000 items. We have to produce them here. Whenever we have small demand, we produce them and store them. Finally, in the pull system, we need all the people or all the teamwork to be cooperative. We have to have a cooperative attitude because we want to reduce the lead time. So whenever there is a problem, we have to communicate. Whenever there is an opportunity, we have to communicate. So we have to have a positive attitude from anybody that's working on a pull system, because we are always at a risk of having an increase in the demand or a decrease in the demand. So we need to respond quickly to that. So we have to help each other in that one. Any questions so far? Now, when we replenish a warehouse, when we buy for a warehouse, usually we have what's called reorder point. In other words, we order a certain amount. Here is order a certain amount. We use them until reaching a certain level, and then we order again. Let's say this is 100. and this is 500. So we order 500 whenever the level reaches 100. The reason of why we order it when we reach 100, because we will be using these 100 items until the next 500 items arrive. So in other words, this 100 is equivalent to what we will be using until the next shipment arrives. So let's say we consume every day 2 items, and the lead time or the delivery time of the raw material is 50 days. So we will wait for 50 days. In each day we're consuming 2 items, so we will be consuming the 100 items here. To be in the safe side, we can increase extra parts as a safety stock. So we can say, instead of ordering at 100 items, we add, for example, 10 items. So that case represents the general formula for the reorder point. It's equal to the daily demand. Here is the demand, or actually demand rate. We consume 2 per day. And then the lead time, it's the time between ordering and receiving the order. In the pull system, what we can do is, what we can conclude here is, the lead time here is divided into 2 things: shipping time and production time, because it's pull. So whenever I order, the supplier will start producing the order. So once again, here is 2 per day, that's the demand, and then the lead time is 50, and then there are some items that I leave aside as a safety stock, so safety stock. So this is the general formula for the reorder point. More specifically, the lead time part here is the part that is affected by the pull and affected by the lean. Why? Because the lead time consists of 2 things: production time and something called conveyance time. Conveyance time is the time to transfer data to the upstream process, plus the time to move material to the downstream, because we have 2 parts here. The first part, I need to order, so this is the conveyance time, or the time to convey the order until it reaches the supplier, and then the supplier has to produce, that's the production time. After the production, the product will be delivered. So the summation of this part plus the summation of this part, this is the conveyance time. So conveyance time is the time consumed in placing the order and in receiving the material. What we do with the lean system is we can reduce the lead time. When we reduce the lead time, then the reorder point will decrease. When the reorder point decreases, then the amount of inventory as a whole will decrease. Here is the main contribution of the lean system. So what we're going to do is, we will have a look at the production. Anything that's not useful will be eliminated. So the result will be smaller production time. Then we will have a look at the conveyance time. It's the time between, or the time for ordering and the time for delivering the product. Once again, lean can decrease this one. Why? Because there will be some contribution here. There will be some cooperation. Data can transfer faster. At the same time, we don't have to ship a lot of material. We just ship small amounts. So the shipping time will be faster. We don't have to wait until we have a large quantity. Just small quantity and ship this quantity. In order to use an effective pull system, we need to use something called containers, small container here. Instead of having a large pallet like that, we don't deal with large pallets. Instead, we will have a very small container here. And let's say that we have daily order for 50 items. We usually use a container here of size 10% of the 50. So the container size here is 5. So we'll be using this unit in our production system. Instead of having the 50 as one unit and moving the 50 between stages, we'll just move 5 units. So we need to know how many container sizes here, how many 5 units like that. This is called now a container. It's not a container like the 50 feet container, or 40 feet container, or 20 feet container. It's just a small container like that. We call this queue. So any container we're using will be carrying 5 items. And we know that the daily demand is 50. So we know that the demand is 50. And then from the production, we know that production time and conveyance time is 2 days. It's something I'm giving it now. It means that whenever you order, the production and the delivery, and in addition to the ordering process, will take 2 days. So as a result, in these 2 days, we'll be consuming, because we're consuming 50 per day, we'll be consuming 100 items, which is 50 times 2. And we're storing 5 in each container. So as a result, we need to order the standard size container, or the order needs to have 20 items. So in other words, here you need to have a container. That container here contains 20 out of these small containers. So we don't order a lot. That's one part. And the second thing, when we move inside the machine, or inside the production system, we just move the 5 items, the container that contains 5 items. The fifth principle, and as I told you, Lean is based on 5 main principles. The fifth one is to pursue perfection. Pursue perfection means that we need to improve. Every time we need to improve a little bit, then cumulatively we'll have a large improvement. And one thing in the Lean is that it has a culture that places a high value on respect for the people. It respects the people, and it's based on the people themselves, the workers, not the professional from outside or consultants. It's dependent on the workers who are doing the job themselves. They can work and improve their work. In order to reach this one, we have to have some principles or some categories to agree on. Number one is acceptance. We need to have a goal, and we need to agree on these goals. And whenever we're doing the work, we need to teach the new employees. And the people who are teaching the new employees are actually the old workers who are actually very good at what they're doing now. They are veterans. The second principle in here is we need to be flexible. In other words, we need to have a pull system, but the pull system means that we have a large lead time. So we need to have to decrease that lead time in order to have a mix between responsiveness and pull system. Pull system means there is a lead time. Responsiveness means that the lead time is small. So we need to work on reducing that lead time in order to have a good responsive system. In Lean, we need to form teams to solve or tackle any problem. These teams have to be cross-functional and cross-organizational. In other words, if we have different organization, there is 1, 2, 3, they are dealing together. If we need to solve a problem, we need a representative or a team member from each of them. Or if these are different departments and the work goes from here to here and then to there, then we need, when we solve a problem, we need workers from every function. So they need to be cross-functional. And we need to give the employees some sort of empowerments. We need to give them orders that they are it's up to them to do reactions to solve or to attack wastes. So we give them some sort of freedom to solve the problems. For example, if the production starts to be bad and bad items are coming up, we can give a worker the possibility that he presses a certain button and he stops the production time, the production line. Even though this is a big problem, stopping the production line is actually a very big problem. However, if we produce bad items, that's much worse than stopping the production line. So we give him some power to do that. We need to manage with data. In other words, if I say that we gained a lot of money, or if I gain 10,000 pounds, it's much clearer than when we use 10,000 pounds, that's clear. But when we say a lot of money, we are not clear. That's the meaning of managing with data. If we say 10,000, we understand what's 10,000. But when we say a lot, there is no clear definition what's meant by a lot. The following thing is that waste by nature is a symptom. It's not the problem. When you have a waste, it means there is something wrong in your system. So you need to solve that root cause. That's the main cause of the waste. It's similar to, as I told you before, having a medicine for headache. If you take Panadol for headache, for example, the headache will disappear. You're not actually solving the headache problem. There is a root cause for the headache problem. When you take Panadol, you're just hiding the problem. So you're treating the symptoms. Goals are met. The people who are working in sales are always suffering from inflated numbers. If I can sell 100, I'll tell the sales people that my target is 1,000 items because I want them to sell more. However, I'm quite sure I'm not going to reach the 1,000 items. This is not a good practice in Lean, because whenever we have a goal, it needs to be, we have a goal here, they need to be realistic goals. They have to be achievable. So instead of misleading the sales team, we say that we need to sell, for example, 300. And we know they are capable of selling this amount. So this is realistic and this is achievable. Another thing that we need to focus on whenever we're doing a business or we're doing a Lean system is we need to do some sort of standardization. By saying standardization, it means that you're doing the exact same steps every time in the exact same way. When you do that, then there is a small variation. because you're doing exactly the same every time, using the exactly same processes. So as a result, you're getting the exactly same product every time. And this simplifies problem solving. Whenever we have a problem, we focus, this is the part responsible for the problem. We focus on this part. But if we are doing the product in a non-standard form, everyone is doing it in a different form, we don't know what is the cause of the problem. We need a process focus. In other words, we need to take a process and changes for outcome change. In other words, we need to focus on very small processes here, and we improve very small improvement in each of them. Ultimately, you'll have a large or a big improvement. So we don't use, in lean, we don't use breakthrough. We don't use a major, or we don't do a major improvement. We just focus on small, quick, successful, small improvements. Now, as we are finished with the main principles of lean, I'm going to teach you some of the tools that you can use in the lean. However, you need to understand that there is no certain steps to follow. In other words, you have to look for the wastes and then try to find which of the coming tools will be good to solve this specific waste. So there is no direct correlation. This one is used in that situation. No, you have to look at the current situation. Here's a current situation. This problem has a waste. Then you look, can I solve it using this one, that one, and so on. So let's have a look at the tools we have in the lean. Number one, we have something called total productive maintenance. What's total productive maintenance? Let's say this is a machine here. We don't keep the machine until it fails. We do regular checks for the machine, and when we do the regular checks for the machine here, we prevent the machine from failure due to any other reason. So it's like the maintenance of the cars. We do a maintenance of the car each 10K in order not to fail. So it's unlikely that the car will fail if you're doing the maintenance. That's the same concept. We have here a machine. Every 2 months, for example, we do a maintenance. That's called total productive maintenance. We're doing maintenance to prevent the machine from failure. The second one is something called group technology. There are two ways to do the work. One of them is to have different departments here. Let's say that you need to do a certain process here. You need to go to department 1 and then you go to department 2. So anyone in department 1 will be helping you, and then anyone on department 2 will be helping you. But you need to move between them. This is unnecessary movement. And the waiting time will be very large because all the people will be waiting here, and then when his turn finishes, he goes here and waits here. So instead of that, we can take one from here, one person from here, and put another person from the next department here, and then the process will become much more improved. It's linear process. You just go here one step, and then next step. You don't have to travel. This is called a group, and this is called the group technology. We can use it for people, we can use it for machines, we can use it for anything. The third one is something called focused factories. Processes designed to satisfy a specific customer segment. Let's say that you have two types of vehicles, cars. You're producing two types of cars, luxury and mainstream, or 4x4. Because the people who are dealing with luxury have a total different way of thinking than the people that are dealing with 4x4, then sometimes we need the factory to be divided into two parts. One is dealing with this one and the other is dealing with this one. So this is called focused factories. Or we have two different factories to deal with them. This one focuses on producing luxury cars, and this factory focuses on producing 4x4 cars or mainstream cars. The the next tool is something called takt time. By takt time, it means, let's say that we can produce 200 per month. If we produce, let it say 300 per month. And the demand is 270. We don't produce 300. We synchronize all the processes. So this is process number 1, this is process number 2, this is process number 3, or this is cell number 1, cell number 2. It's like what we did before in the assembly line balancing. So that this is 270 per month, and there is 30 days per month, for example. Then we need to produce 90 here, 90 here, 90 here. So the synchronization time is 90. After 90, all the cells exchange parts from this one to the next step, from this one to the next step. But the actual work can be less than the 90. For example, this can finish, instead of 90, can finish 95. I will set it to finish 90. So in other words, we're producing the amount required or the rate required by the demand rate. What's the demand rate? We're producing at the same rate of the demand rate. The next tool is something called Kanban. It's similar to the pull system. It's output generated in response to actual demand. Here is what Kanban is doing. Kanban cards shows typically production quantity derived from 2-bin inventory systems. What's 2-bin? Let's say that you have here 2 bins. One is full here and is used, and the other one is full and it's not used. When you use this one, so we keep using this one here until it's empty. When it's empty, we start to use the second one and we fill this one again until this is empty again. We return back to this one. So whenever one is empty, we switch to the next one and we fill the empty one. From the same principle, and instead of having 2 bins, we will have 2 locations. Here we're producing, for example, and here we're storing some amounts. Let's say we have a container that contains 25 items. And then when we have 5 items left, we need to bring another 25 items. So what we do is we bring a container that contains 25 items, and then for the last 5 items we group them together and put them in a container or in a plastic bag and put a card with them. This card is called the Kanban card. In that Kanban card, it says what's the name of this product, where it is located, and how many items to produce. So for example, here it will be written that 25 items are needed. So whenever you reach this one, you open the last 5. You have a card, you put the card here. in a place, in a holder. And there is a person that searches for any Kanban bank cards here. He gets the Kanban card and he knows that he wants to bring 25 items from inside and put it once again here. And for the last 5 of them, he has to group them together and put the card once again here. So what we do here is we're maintaining the pull production system. We'll only get the product whenever there is a need for that one. So what we do is we have here 25 items, any quantity. And then for the last sum of them, let's say last 10, last 15, usually this is equivalent to the lead time. In other words, you will consume these 5 items while you're bringing the 25 items. That's why we group 5 here. Then in these 5 items we have a card. This card means that you need to bring another quantity. In this card all the information is available. What is the name of the product to bring? What is the quantity to bring? What is the quantity here to group together? So the worker will take the card from here. We put the card here and another worker takes the card from here. His responsibility to bring whatever written in that card. So he goes and brings another container. In that container there is 25 items and it's written in the card that you need to bring to group 5 items and put the card inside them. Likewise, this is called withdrawal. Why withdrawal? Because we're bringing from the inventory. Similar to this one, the inventory will consist of 25 items and 25 items and 25 items and 25 items. And then at the last 25 items, there is another card. This card is called a Kanban card again. This card says, we're about to finish. You need to produce 1, 2, 3, 4 containers. Each container contains 25 cards. So this is called the production card. So whenever the worker here finds that he's getting the last one, he takes the card and put the card here. Another person will take the card and give it to the production system. The production system will produce 1, 2, 3, 4 containers, and each container has 25 inside them. So it's a way of whenever to apply the pull system by saying that whenever there is a card, it means there is a necessity to produce or to bring the product. So the card means we need something, and inside the card everything about the card, about the thing that you need to produce is written. Everything. Here is the case. This is an assembly line. We're producing. We're getting the products here and return it back here. In that card, when we finish here, whenever we're consuming a certain amount, we have a card here, and he brings from A, move it to B. We take from B, whenever we finish it, we bring a card here. Now, A is about to finish. When it is about to finish, we send another Kanban card here to the production that you need to produce again. So we produce again. Here is a sample of the Kanban card. It doesn't have a standard format. It's up to you. In that case, here is the part number. What is that part? When you bring a box, how many should be in the box? Where can you get it from? And where are you going to put it in? So it's complete information about this one. Here is another one. Address, part number, route, any details about the products you need to bring from the warehouse. Here is how a single card Kanban system works. When we take one from here, it has a label here or card. We put the card here. The card says that we have the magenta or the pink card here means that we have consumed one of the cylindrical parts. So please prepare another one. So these people will prepare another one. What they're going to do is they need to bring one from here and they fill it with the circular or cylindrical parts and put it back again. Now, when we finish this one, there will be another card here says that we are about to finish the carton that are available here. This card goes to these people who are going to make another box like that, cartoon box. So once again, if you don't understand this one, what we do is when we take one from this one, it has a card here. We put it here. It means we took one, you need to produce one. So this worker here will go and take the cards from here. The meaning of this specific card here that we need to produce circular parts. So they are going to fill an empty box from here with circular parts. You put it here. So whenever you remove one, you're getting one collected. Likewise, you're moving from here. After you remove, for example, 3 items, there will be a card. This card means you already consumed 3 boxes, you need to produce 3 boxes. So this is called the production Kanban, and this is called withdrawal Kanban. Why? Because these people are getting the products from the warehouse. Well, this takes place in the warehouse. However, this is production. This takes place in the production line. So we're getting back to the same question. How many containers to use? It's the rule that we used before. K is equal to D, which is the demand rate, C plus P, and then there is a safety factor. Safety factor here is 1 plus alpha times 1 plus alpha. That's something new, divided by Q. So for this example, they want the container to contain 22 items. So this is Q. So we need 22 items here. And daily we're consuming 2000 items. So 2000 items here. And the production and delivery takes 0.02 plus 0.08. So it's taking 0.10. And we need to take a safety stock of 10%. So 1 plus alpha, it's 1 plus 0.10. If you substitute here, you will find that this is 220 divided by 22. It means we need to keep 10 containers. So in other words, we changed the way of doing the business up to pull. How to do that? We need to store 10 containers here. Each container contains 22 items, and when you use this one, you're using 22. And then you use Kanban card to bring the next one, and then use Kanban card to bring the next one. And when you're approaching the last 2 or 3, then there is another Kanban card to produce another 10 containers, and so on. So once again here, we have a box. This box called this box called container. This container contains 22 items. Let's erase everything to review it again. So this contains 22, this contains 22, this contains 22. I need to know how many to store in the warehouse. I don't want to store a lot of items. So what we do is we compute D, which is 2000, times P plus C, which is 0.10, times 1 plus alpha, 1 plus 0.10, this is a safety factor, 1.10, divided by 22, that's the value in each container. So we need to store 10 of these. So how we'll be doing the business? We're going to store 10. This is inside the warehouse. In the production unit, we just use one of them. So what we do is we use one here. When we use one here, in the last few items, we have a card. It means bring the next one. We bring the next one. In the last few items, there is a card. It means bring the next one. That's withdrawal cycle. We're getting it from the warehouse. We withdraw it from the warehouse. And then for the last few pieces here, there is another card. This card says you need to produce another 10 items, 10 containers, because we're running out. This is the last 3. So this is a Kanban card, which means you need to produce another 10, and so on. The next tool is called leveling or mixed model or Heijunka. It means instead of building a large quantity, let's say you need 1,000 items. Instead of producing the 1,000 items in one run or one job, one batch, no, produce it 100. So 100, small amount. You don't need to store a lot of items. You don't have to pay a lot for the waste of production and the waste of overproduction and the waste of storage. You're not going to pay. And you need to do it 10 times. So instead of keeping 1,000 items stored in the warehouse, you're just keeping 100 stored in the warehouse and you're consuming them until you produce the next 100 and so on. In order to do this, we need to do the setup as fast as possible. This is called setup reduction. Because we're producing smaller amounts, we're shifting from A to B to C. So we need setup here, we need setup here. So we need to reduce the setup time as fast as possible. We need to do it as fast as possible. So when you change production from one item to the next item, you need to do it as fast as possible. When you improve this one to be very fast, so that it's between 0 and 9 minutes, this is called single minute exchange of dies. If you can change the setup time or reduce the setup time to be between 0 and 9, that means single digit. Then we call it single minute exchange of dies. You can change from one production to another production in a very small amount of time, less than 10 minutes. The next tool is called statistical process control. In a statistical process control, we can predict what may happen. For example, let's say that you're producing this amount and that amount and this amount and that amount and this amount and this amount, and suddenly you're producing like that. It means the production is declining. Before you know that we have too many bad items, or there is a large reduction in the production, we can predict that there will be some sort of reduction in the process. This is called the statistical tool, the statistical process control. We use the statistics to predict what may happen. The next tool is called visual control. And instead of having things written as words or sign as words, we can have something that is easily identified and easily interpreted. For example, if I have something written like that, red, something red here, and danger. Let me write it again in a clearer way. There is a sign here, and there is a circle and in red and something like that. This is probably means that you're not allowed to enter. If there is a smoke like that, and there is X, so smoke is not allowed. Smoking is not allowed. So visual control means let's have some sort of signs that can be immediately visible and very easily to interpret. And instead of having orders or something like that, or time or letter or memo, or we have visual signs. The next tool is called Kaizen event. This is one of the most important tools of the Lean system. In Kaizen event, we form cross-functional team. We form it for a short term that focuses on one problem and tend to improve it in a fast way. So we form a team. As I told you, teams before has to be cross-functional from different functions, and they work on their work, improving their work in a very short term, and they focus on one term, and they are workers actually from the production line. It's not inside, not consultants or not people from outside. This is called the Kaizen event. So Kaizen event is like forming a group, but instead of group of experts from outside, it's a group of experts from inside, workers who are doing the work, so they know what they are doing, so they can improve their task. The next one is something called Gemba. Gemba means to go and see everything in person. If I ask you what are the steps to renew my license, you tell me you have to check the engine and pay the fees and get your license, car license. However, if you go, you will be told to go upstairs, then downstairs, then go outside, then go inside, then do something, and then. So if you go in person, you will hear a total different story than what the people tell you. So Gemba here means if you want to do a lean project, you need to go and see by yourself what's going on, and instead of relying on what you are told. The next one is called Bokayok. Bokayok is designing a system so that mistakes are impossible or immediately detectable. In other words, let's say that let's have a look at the original iPhone charger. The original iPhone charger had something like that, socket like that. When you click it, sometimes you can enforce it in a different way or a wrong way. So sometimes it's connected in a wrong way. So instead of that, they improve it to be like that. What happens for this one is if you insert it in one direction or the other direction, it will be correct. So this is a redesign of a process, the process of inserting the jack into the socket. It's now impossible to make a mistake. Here there was sometimes a mistake. Sometimes you insert it correct, sometimes you insert it the other way, and you keep pushing. Sometimes you keep push until you break the phone itself. So this is called Bokayok. It's a redesign so that the new design does not allow the error. Or if it allows the error, then it's detected immediately. The next one is called 5S tools. 5S comes from the 5 words sort, straighten, scrub, systemize, standardize. In other words, it's a housekeeping. It's effective housekeeping. In other words, let's say that you follow a worker that is doing a regular maintenance on the car. You'll find that the worker goes to the drawer to get some tools and then return back, and then goes to bring something else, and then he goes back, and then he realized that he brought something wrong, so he goes back. So instead of going and returning and going and returning, and sometimes he wants to search where is the tool, instead of that, let's put them in an organized way. Here is an organized way, and give them some codes. This is number 1, this is 2, this is 3, and put in each one a shape of what is expected to be here. Let's say this is a screwdriver, so here is a screwdriver. This is drawn on the wall. So everything now is in order, it's sorted, it's straightened. Whenever you need something, you just get it by color or by shape. It's much easier than just searching for it. And it's standardized, so if you go to another location, you'll find the same way of organizing the things. It's now systematic, everyone knows how to do it. And whenever you return any product, let's make sure that if you insert the screwdriver here, it fits. If you put it anywhere else, it doesn't fit. So you make sure that it's organized in a way, so whenever you try to do it, it's in the same way. It's very easy to bring the product. It's very easy to spot where it is. It's very easy to do. That's the 5S. So 5S means look at the current situation. Is it organized? Is it easy to get the what you want from the location? Do you consume a lot of time on finding the product? Do you find some product not in their places? If so, try to reorganize it in a way so that it is straightened, it's easy to find, it's colorly coded, it's there are notes to find them, it's easy to find them, it's repeatable everywhere, and everyone knows how to do it. The next step is called, or the next process is called simplification or standardization. It's removing non-value adding steps, making process exactly repeatable. Standardization means everyone is doing the process in the same step, in the same way. So make sure that everyone is doing it in the same way. So you have a look at the process and make sure that this person is doing it in the same exact manner, like this one, like that one. So this is called the standard. And make sure that whatever you're doing in this step here is actually value adding activity. So this is called simplification or removing non-value adding activities. Anything that's not adding value, you need to remove it from here. And when you remove it from here, it's removed from everywhere because it's this standard. The next tool is called Jidoka or automation. It's not automation because it's a mix of automation and manual intervention. It's like, let's say that we have an elevator, and this elevator here needs to stop at this location. If he misses this location, I need to have the elevator to stop immediately. So this is the automatic part of it. It will stop here. So this is discover abnormalities. When we have something that's wrong, try to find it fast. And then we stop the process. We stop the process here. And then fix the immediate problem. What happened here? Let's say that we overloaded the elevator. So we need to put a sign, for example, that the maximum load is whatever. So this is an immediate fix. It's not the root cause. But the root cause is we need to investigate and find the root cause. What is the root cause? It's not only the label. We need to detect it before the elevator moves. So in order to improve this one, we need to add some sort of sensors. When the load exceeds the limit, this sensor prevents the elevator from moving. So in other words, it's not an automatic process. It's an automatic in the sense that it is stopped and we find the problem automatically. We find the problem here. This is an automatic part. And then this part is manual. We stop the problem and we fix the problem for now. We stop the problem here and we put a sign. This is a temporary fix. It's not a total fix or a root cause fix. And then this part is extensive manually. We investigate and solve the root cause. And then when we implement the root cause, we implement it to be automatic in the problem in the future. So it's a mix of automatic and manual intervention. So once again, if there is a problem, detect it. That's the automatic part. And then stop the process and solve the problem for now. That's a fast intervention, manual intervention. And then think and investigate what is the root cause behind this problem. Solve the root cause, solve the problem totally, and try to make it automatic so that next time the problem will not occur. That's the Jidoka. The problem is I don't want the system to stop. So I want to fix the root cause behind the problem, and I want it not to be repeated again. Another tool that we will have a special lecture for it is called the value stream map. In the value stream map, we track all the processes within the supply chain. For example, here is a customer. The customer orders from my production department. The production department orders from the supplier. The supplier sends a car. The car arrives and the material is stored in the warehouse. And then there is process number 1, and then it moves from process number 1 to process number 2, and between them there is part in process. So basically I'm drawing a graph that represents all the steps taken in the supply chain. So now we covered all the tools of the supply chain. As I told you, all the tools of the lean supply chain. As I told you, there is no blueprint to follow. It's up to you. So we need to know, why do we apply lean? We apply lean because we need a reduction in the inventory, lead time, and buffer. That's why when you purchase something, you don't focus on the price of the item, just the price. You need to focus on the total price. Why the total price? Because the total price includes the selling price and the inventory price and the transportation price. That's why when we deal with lean, we want to reduce the lead time. So usually we use geographically close partners to reduce the distance and reduce the transportation cost. And when we have different suppliers that are providing the same product, we try to focus on 1 or 2 of them, fewer suppliers. Because when you buy from fewer suppliers, the demand will be large per supplier. For example, if I'm ordering 100 for each one, If I deal with only 2, then I'm going to order 200 instead of 100. Because I'm buying 400 from 2 instead of 100 from 4 suppliers if the demand is 400. Focus on root cause. Whenever you solve the problem, don't focus on the reason of the problem. Focus on not the symptom of the problem. Focus on the root cause of the problem. Work with, not against suppliers. Treat the suppliers here as a part of your company. They are not competitors. They are working for you. They are not working against you. So whenever you work with them, not against them. So when we design something and we need it to be lean, we strive to meet the objective of exactly meet the customer needs. We produce only what the customers want. Support cooperate strategy. We support the strategy of my organization of either having fast delivery or cheap products or high responsiveness. And whenever you're doing anything, try to eliminate waste out of that thing. One of the wastes that we didn't cover so far is called product design. The product design itself, sometimes it has some wastes, such that you produce an overly complicated product. Instead of that, try to design a product that is produced or assembled or used in a few simple processes. Don't make the precision too high. For example, if you're measuring the time, don't measure the time by microsecond if you're measuring something that is daily used every day. It's used in hours. So try to use the precision that is good for you. Control variability. For example, if I'm producing a table, that table has a width of 1 meter. The production can have some variability from 1 meter, so it can produce it as 1.05 meters or 95 meters. Is it acceptable or not? So define what is the accepted variability. Don't make the product too sensitive, so that it's easily damaged. Don't use immaturity or untested technology. That's a new technology that has not been proven yet, and it's a weird technology. Don't use it. Don't ever design something that is dangerous to use, either to the customer or the environment. Don't design the product that it needs very high skills of workers or customers to use or assemble. Try to make it as simple as possible. As I told you before, the word just in time is another word for using the lean system. Actually, it's a much advanced stage. If you're able to draw a value stream map, we will have a lecture on this one. Then the next step is you can reorganize your process or make the process flexible. If you're able to do this one, the next step is to make the product standard and to make fast setups. If you're able to do these two things, you can improve the maintenance. If you do these three, you can do automation. If you do all of this, then you are ready for just in time. Because just in time, you're not able to afford any failure in the machines. So you need productive maintenance. You need the work to be standard. You need to change between parts in a fast way. You need to detect errors and solve it fast. You need to organize the way in the best possible way. So everything is needed before we reach the level of Heijunka and the level of just in time. Similar to this, the definition of Toyota Lean Production House or Toyota Production System is another name for the Lean. In order to start to build the house of Toyota, you need to have preventive maintenance, you need to have good quality assurance, you need to have a stable manufacturing process, you need to have a stability. If you can do that, you can do the Heijunka, production of fewer items. You can do the 5S, you can do standardizing work, you can do the Kaizen. If you can do that, you can do just in time, you can do Jaiduka, and then you reach the goal of lowest cost and shortest lead time. So you need to do, or you need to improve these steps first before you reaching the higher steps.